Hey guys, I'm back again and sorry for the sheer delay I have made in uploading new video. So today I have made a to-do list app in C using linked list. So today I will share you how I developed the thinking to make this from how I developed the code and every logic behind every line of this code. So before going to proceed, let's run it to see how it looks. Okay. God, come on. Okay. So this is basically the welcome screen of the app, splash screen type a sense I wanted to give. So press any key to continue. So pressed. Okay. Oops, sorry. Yeah, fine. So these are the basic functionalities that this app can perform. Like you can see the to-dos, you can create new to-dos, you can delete your to-dos, you can update your to-do list, and you can exit the app. So let's try this out. Empty to-do because we haven't created a list. So create your to-dos. Okay, want to add? Yeah, sure. Add it. Maybe wake up in the morning. I rarely do it. Yeah, I did like code all the day. I love it most. Like solving maths. I love it too. And well, I love it the most. Okay, so let's see the list. Yeah, you can see that there are automatic numbering like 1 2 3 4. Accordingly you have made the choices. So now let's delete some. Okay, let's delete the number 3. Press any key to continue. Okay, enter the number of the to-do you want to remove. Yeah, let's see whether it removed it or not. Yeah, I have deleted the solving numericals and you can see the number has been automatically updated. This was previously number 4 and now it's number 3. Fine. So now let's remove one more. Like let's remove the first one. Okay, let's see again. Fine, the numbers have been automatically updated and now this was number 3, this was number 2, now this is number 1 and this is number 2. Excellent. So let's update the to-do. I did like one more, like let's see. Yeah, 3 and 4. So this is pretty much of this app and now exit. Okay, so this is pretty much my to-do list app can perform. Okay, so the first question is how I thought to make this app. So basically this is for the beginners who learn any concept and then think to implement this in project. This is for them. Like if you find it hard to grab any topic to make a project on, to make a little project on, just look at your surroundings, just sit back, relax and think what the problems you face every day, and you think, oh, if I had a software then it would be easier for me to face the problem. Like I really need to do softwares because I have a cramped schedule every day. So at the end of the day I keep forgetting, oh my god, I needed to do that, oh my god, I needed to do that. So, and also to-do list makes me really focused about my daily routine. So that's why it was very easy for me to think to develop a to-do list app. And again I thought to make it using linked list so that I can brush up my linked list concepts. So that is how I developed the thinking to make this, because this is what you needed. You should not stop yourself, you should not restrain yourself by just learning a concept like learning linked list, a data structure of course, and then just moving to another concept. No, just sit back, relax, slow down, make some project using what you have learned, and then move to the next topic or next conception. This would enhance your learning experience, definitely. Anyway, I'm talking too much. So basically I've already told several times that this is practical implementation of linked list. So if you know what is a linked list, if you know how to handle linked list, if you know the basic operations performed on linked list like creating nodes, deleting nodes at any given position, as you can see that I have deleted the list at any position, and adding node at the end of the list, because you can see from the output that the list was added at the end. So basically pretty much of this. So I'm not going to translate every line by line of code because that would be my code. Rather, I would explain the logic behind every line I have written here, and will also help you develop the thinking to make something like this on your own, because this is highly important. Okay, so, and one more thing, I had a requested video about making a snake game. So I made the snake game, but there is one problem. Like the problem is with my CPU, because there is a function called systemcls, and that is completely Windows environment dependent, and the function clears the console every time you use the function. So I have used the function in that game too, and what it did, it actually kept the console clearing so fast that the console started flickering irritatively. So, and when I googled it for the reason, I found it that this is due to the processor speed, and I had really nothing to do with it. So what I thought to do, I just, since systemcls is a Windows dependent function, so I thought to remake the game in Linux environment, and in Linux I need to use something else function like clear, and I also needed to use the ncurses, I also needed to include the ncurses library. So I am making the game, so I think I can complete it within 2 days, and then I will upload that. Okay, and sorry for the delay because I was damn busy with my internship and college and a lot. Okay, I'm again talking a lot. Anyway, so let's start with the game. So if you know what is a node in the linked list, then you should know, you should find an analogy here. So this is my own data type, to do. And you know, in C, if you want to create a data type, you have options like structure, enumeration. So here I have used a structure. This is basically how node is created in linked list, and this is basically a node with three, okay, you can think of a node like a room. Okay, like a room with some partitions. Like this is a room with 3 partitions. One contains the character array that will basically keep the data, our list item, like wake up in the morning, solve maths code, all that like that. And this part, this integer variable count will have the number of like 1 2 3 4. We need to store that 1 2 3 4. Okay, so this will keep the track of the number of the nodes or my to do, and this pointer will have the address of the next node. So this to do. Okay, so since I really didn't like to use the struct to do every time I use this data type, so I have typed it here as to do. Okay, so if you don't know what is linked list, then you will find this a bit tough, I think. So I highly recommend you to go brush up your linked list concept and then come here to enjoy this little project. Okay, so I am giving you a basic logical idea of linked list. I have heard this in a YouTube video when I was in class 12, I think so. Now I'm in second year. Okay, so, and the explanation was too good to understand, so I'm telling it again. Like suppose your teacher has taken some of your classmates to a cinema hall to watch a movie. And you know, to watch a movie you need to buy some tickets. So now the teacher has the responsibility to safely to provide you security and safety, so that none of your classmates are left in the cinema hall or left somewhere. So what the teacher does, he keeps the ticket of the first student to himself, and the first student keeps the ticket of the second student, the second student keeps the ticket of the third student, the third student keeps the ticket of the fourth student, the fourth student keeps the ticket of the fifth student, and suppose there are 5 students, so the fifth student has the ticket of none, the fifth student has no ticket. So thus the teacher carries out an excellent plan to count all the students, those who are present in the cinema hall. So this is basically the logical idea. This is exactly the logical idea of linked list. Like, linked list has a start pointer that will point the first node. Initially this is null because we haven't created the linked list yet, and here the linked list is our to-do list. So, and this every node is a student, and the first student in the link part of the first student, in the link part of the to-do node, the address of the second node is kept. In the link part of the second node, the address of the third node is kept. In the link part of the third to-do node, the address of the fourth node is kept. So by means of node you can think a box or a room with some partitions, and I hope it's a bit clear for you if you are new to the concept of linked list. Linked list is a data structure, highly convenient, highly important, highly usable. So still, if you don't understand, please go and brush up your linked list concepts, and please go and learn the basic linked list functions like creating node, deleting node, updating node, because these are what I have used in this program. So initially this is null. I have said why it is null because now start pointer points to nothing. Start pointer is the teacher. Now in the cinema hall there is no student, so he has no ticket. Okay, so this is our main program. So first, since you can see from the output that this is a menu driven program, so if there is a menu, there must be some loop and some switch case. So here is the welcome user function. So this welcome user function is to give the essence of a splash screen. Okay, so this contains nothing, just some printf statements. You can easily make it as per your own. And this system color 4f is to change the console color and the font color, and the system pause function is to reasonable for the press any key to continue. It will accept one key and then continue to the next output. And okay, this system function is completely operating system dependent. It won't work unless your operating system is Windows. That is why I am in a problem with the snake game. Okay, so this is basically a welcome user, just nothing, some combination of printf statements. Okay, so here this is the infinite while loop. You can see while one means the condition will be always true, so the loop will run for eternity unless and until we give some break statements, we give some end statements explicitly. So again, to change the console color, and this system CLS will clean the console. This is just to avoid the redundancy of the menu, just to make the output a bit cleaner, a bit professional touch. You can make it in your own way. The UI doesn't matter. What matters is the logic and how you execute your program, how you write the clean code. Okay, so nothing much to explain here. The menu and the acceptance of the choice, keeping it in a variable because the user will give any number as a choice 1 2 3 to access the menu, and now passing the choice in the switch to match the choice. And to keep my main function cleaner, I have made methods for every option. Like to see the to-do list, I have made a method see to do. To create to-do list, I have made create to do. To delete to do's, I have made a method delete to do. To update to do, I have made a method update to do. And to exit the app, I have used exit 0. Exit 0 means the app has the program has been executed with success. And to use exit function, don't forget to include stdlib.h header file, because unless you do it, your exit function won't work. It will generate error. So this is my clean and clear main function. I like to keep my main function clean. Okay, so first the see to do function. So what it does, it will actually print the to do list for you. So every time, as you can see that when the user presses gives the option 1, because option 1 was to see to do, we see a new console, because every data, the menu doesn't appear anymore. This is due to the system CLS function, just to create a cleaner output. Okay, so this is basically what is called traversing nodes in the linked list. If you know how to traverse the node in the linked list, then this is basically that. So this is the code for the traversing. So if you know how to do it, then there is no point of explaining the line by line of code here. Rather, I am showing you some pictures so that you can understand what I have written here. That would be more convenient, I think so. So this is how our to-do list looks like. These are the to-do nodes. A box with 3 partitions, one with the count, that is the number. This is 1, 2, 3, 4. These are the data part, like wake up in the morning, code all the day, solve numericals, have a nap. And these are the link part, that is the first student keeping the address of the second student keeping the address of the third student keeping the address of the fourth student, and the fourth student has the address of null, nobody. And this is the teacher that has the address of the first student. So our job is to traverse every to-do node here, and while traversing, printing the data. So to access every node here, because if we need to print the data of every to-do node, then we need to access every node. To access every to-do node, we need a pointer. So we have a pointer already stored, but we can't move start because the teacher's position here, the start's position is fixed. So for that reason, let's take another pointer. For example, maybe temp. I'm denoting here with T, and let's make it point to the first to-do node. And now let's make it point to the node that is pointed by its link port. Okay, the line written here. Print the data of the first node, like the node, print the data of the first node to, suppose I'm taking it for the first node. Print the data of the first node in the console. This is just a notation, a simple syntax, and we need to clear the buffer here because I've used puts function. And then let's make it point to the next node that is pointed by its link port. Pretty much the same thing here. First time temp points to the first node, it prints the data here, and now I make it point to the second node, prints the data here, and now make it point to the third node, prints the data here, now make it point to the last node, prints the data here. So this process, so we need a loop to run this process. And when will the loop stop? Simple, when the T will be null. So simple, when T will be null means there will be no node, so the loop will stop. And there is one more case when there exists no to-do nodes. That is the first case when we haven't created any to-do list. So in that case the start will point to null. In that case the start will be null. So for that case we will print a message like empty to do, we have seen in the output. So this is pretty much of the logic of traversing and printing data of to-do nodes. So that's it. This is pretty much of our C to do function. Here is the looping, and you can see the code here. Okay, I will give the code in the description link. You can see it from here, but again there is no point of telling the meaning of translating every line. Rather, I have told you logically this. So your task is to go learn linked list and then implement it in your language. So basically, if you learn the logic, then coding is nothing except some syntax, just nothing except syntax. What is important? You need to learn the logic, and I really hate memorizing things. Okay, so next is the create to do function. So what we will do, this will basically create to do nodes. So here is two cases. Number one case, when the list will be empty, that is the first case, and that will occur only once, because the list will be empty only once. Because if you create at least one to do node, then there will be at least one to do node. So the start pointer will point to that node, and the list will be no more empty. So here is the case of the first case, when the start pointer will point to null and the list will be empty. So we need to create a node. And here is the case for the rest of the cases, when there will be at least one node or two or three nodes. That is, there will be at least one student or two or three students in the cinema hall. So this is basically this. Again, I'm not translating every line, rather I am showing you graphically the logic. And wait. So this is the first time when the start is null, means there is no node existing, there is no existing node. So we need to create a to do node with dynamic memory allocation. Like here you can see, like this is the first case. Okay, before that, since the user can add to do nodes, to do list repeatedly, so we have used an infinite while loop here, because while 1 this will be always true, and this is an infinite loop. And since I have used infinite while loop, so we have to give some conditions explicitly to come out of the loop. And this is this, like I have asked, every time the user adds an item, adds a to do in the list, I will ask the user for further if he wants to add, yes or no. If he gives any other character other than n, the loop will run again and again. And if the user gives character n, that will be stored in the k variable. And if the user given character is n, the loop will break, we will come out of the loop, and we will land in the menu again, main menu again. Okay, so I have used this type of code very often, like using while loop and then giving some conditions explicitly, like yes or no type condition. I really like to use this. And this f-flash stdin to just clear the buffer. This again machine dependent problem. So now suppose there is the first case, and the user, and there is no to-do list beforehand, and there's the first to do the user wants to make. So dynamically this to do type of pointer, because we know pointer points to the memory of each same data type. So t is a to do type of pointer as well as temp. And now we have created a to do type of memory block using dynamic memory allocation, calloc. So if you are really using dynamic memory allocation like calloc, malloc, free functions I have used here, don't forget to include stdlib.h header file or alloc.h header file, otherwise they won't work. So now this code, let's see it here. So now suppose this is our new to do that is presently pointed by t, because this is a memory block, and if we want to perform some actions, if we want to manipulate this memory block, we need to know where this memory block resides in the memory. So for that reason we need to use pointer. It holds the address of this memory block. So suppose this will be the first to do of our to do list. So first make this null, because this is the first student, this is the last student, and the last student doesn't keep any ticket, so its link part will be null. This is the count part, this is the data part, and this is the link part, so its link part will be null. And sorry, so suppose we need to keep this to do in our main to do list. So now there is a node, there is a student, so now the teacher needs to keep its ticket. So now it won't be null anymore, and it will point here. This is basically what in the first case we do. So now we have at least one to do in the list, and so the first case won't be occur anymore. So now the case will be different, that is the else part. Now control will not go any here, now it will come to the else part if the user has given y. So now again we will create a to do type memory block that will have three partitions like count, data part, and link part. So now we will ask the user to add some data. We will put the data in the data part of the new to do node, and now we will make the linking portion, that is to put the to do in the main to do list. So for that we will do, so this is the new to do node. Presently its address is held by our temp pointer. Logic same. To manipulate this to do memory block, we need to know its address, and its address is kept by temp temporarily. So it's a temp pointer, and it's of to do type because pointer points to the same memory block of its type. Okay, so what we'll need to do, so now t points to the first node. Okay, so the teacher's position, that is the starts pointer's position, is fixed. So t points here. Simple, we will make t point here, that is t's link part. T's link part will point to this node, and now t will point here. Okay, I showed this operation before. No, at first t's, okay, let me do it again. Okay, so t points here, so now t's link part will point to this node. It won't be null anymore because there is a second student, and now the second student's ticket will be kept by the first student. And to access the second student for further time, we move the t to point the second student, and when there will come another third student, we will do the same operation. Suppose this is the third student and this is the second student. Again t's link part will point to the third student, and t, after making the linking, t will point here. So this is pretty much of creating nodes. You can see from here. So these are the logic, and if you still can't understand, then please do revise your linked list concepts. So, and if you want me to make a video on linked list, I will definitely do so. And now here is a fixed count. So fixed count fixes the count of the nodes, that is the number of nodes. You can see that the number of nodes were automatically given and updated after deletion and updation. So this is kind of, okay, where is my fixed count? Okay, so this is kind of traversing, and in the previous case C to do function, we traversed the to do list and printed the data, and here in the fixed count function we will traverse the to do list using this to do type of pointer temp, because the start pointer's position is fixed. We can't move the teacher, so we need a bearer to move to the position of every student and ask for the student's favor for any reason. Like here, this bearer, this temp pointer, moves to the each student and numbers that student, like gives a cheat, that is I, which has a value 1. So while traversing, each student, this bearer temp gives each student a number. It gives the first student number 1, it gives the second student number 2, it gives the third student number 3, just to track the counting. This is basically the logical thinking behind this fixed count function, because I have used this counting a lot of times in the program, so I needed to use a separate function to fix a count. And through this count variable, I have accessed the node, I have accessed the student to remove, to make them get out of the cinema hall or to make them in the cinema hall, like that. So now the del todo function. Okay, so here where I was, so basically this is the create todo function and fixed count function. So now the del todo function is just to delete the to do node at any given position given by the user. So if you know how to delete a node at any given position in the linked list, then this is what this function does. Again, systemcls function to clear the console, to give a neat look. And again, I'm telling you, this is completely Windows dependent function, it won't work in Linux. Okay, so for deleting at any given position, okay, for deletion purpose there can be two cases, like when it would be the first student, when we will need the first student to make him out move out of the cinema hall, or any student, maybe second, third, fourth, or even the last student, to make him get out of the cinema hall. So for that reason we needed two bearer, because suppose if we need to make the second student out of the cinema hall, then the second student has the address, the second student has the ticket of the third student. So if we make the second student get out of the cinema hall, the ticket of the third student will be also gone, and now if the checker comes and asks the ticket for the third student will be really harassed. So we need to keep that in mind. So for that reason we need a bearer. We need basically two bearers. One bearer will check the counting, whether it is the first student, whether it is the second student, because the user has given already the number which student he needs to make out of the cinema hall. Suppose it is the third student, so one bearer has that information, like bearer temp has that information, and this temp checks whether it is the first student, no, okay, whether it is the second student, no, okay, whether it is the third student, oh yes, it is the third student, so he gets the match. Now it is the duty of the bearer 2, that is the temp one. What he will do, he will start traversing from the first student. He will just stop with the second student, because the match is found with the third student, so he will stop at the second student's position, and now he will tell the second student, because second student has the ticket of the third student, and now we are making the third student move out of the cinema hall. So the second student has, actually there is no point of keeping the third student's ticket, because the third student is going to be out of the cinema hall. So now the second student needs to keep the ticket of the fourth student, because the fourth student ticket is kept by the third student. So what this bearer will do, this bearer will give the ticket of the fourth student to the second student, so that the list doesn't break up. So this is the story behind the deletion at any place. And if it is the first student to be moved out from the cinema hall, then what will be the story? This will be much more easier. There we don't need two bearers, because already the first student is pointed by the teacher. I mean, the first student's ticket is kept by the teacher. So what the teacher will do, because it's a rule that the ticket whose ticket, that the teacher will always have the first student tickets. So as very simple, the teacher will give the ticket of the first student to suppose this bearer, and himself will take the ticket of the second student from the first student. So now the teacher has the ticket of the second student, so now that second student is considered to be the first student. So now the first student can easily move out of the cinema hall, and now if the checker comes and if ask for the ticket of the second student, the teacher can show the ticket of the second student. So this is the code here, and after every deletion we will call the fixed count function to give new numbering to the students. So this is what it does. This is the logical story. I have used loop and this 2 pointers. So if you can see from here, I'm not going to translate every line of code, but if you have heard the story with attention, proper attention, then you can understand the code too. So by means of moving out of the student is to use the free function. There's a dynamic memory allocation function, and this is the basically story of deletion. So now another function is to update to do. So again I have used system CLS function, Windows dependent function, and to clear the console to give a neat look, again I have 2 bearers here, t and temp of to do type, and a character variable k, again an infinite loop. So if an infinite loop, then definitely needs to have a break condition explicitly, and same type of code like we have seen in the create to do function, just to give a similarity with the create to do function, create to do's performance. Like it will ask the user to whether he wants to update or not. If yes, then this code will be executed. If no, then it will come out of the loop. And flash stdin to clear the buffer, because my computer is really 4.5 years old and it needs such type of forcing buffer clearance. Anyway, so what it does, we just ask the user to give some data and we create a new node. So okay, so if you know to add a node at the end of the linked list, then this is basically this. We have created a new to do type of box that contains 3 partitions, one for the count, one for the data, that is the to do, like wake up in the morning, go to sleep, blah blah blah, and one to have the address of the next node. So and now this memory block is pointed by the temp pointer, that is 1 bearer, points to this new student that would be put in the students list in the cinema hall. So this student hasn't made entry yet, so this student's ticket is kept by this temp bearer. Now we ask, now we put the data given by the user in the data part of in the data partition of the new to do node. Since we have used gets, I needed to use this flash stdin to clear the buffer. This is machine dependent entirely, and now made the link part null, because this student is going to be the last student in the row, and the last student is really headacheless, because the last student needs not to keep the ticket of anyone because he is the last. So its link part must be null, and now he enters the cinema hall. Now comes another bearer, t of to do type. He starts traversing from the start, means he starts traversing, t equal to start means starts points to the first student, first to do node. Now t points to the first to do node and starts from traversing there until and unless it finds the last student, means last student in the row, because this new student hasn't been seated in the row. So until and unless it finds the last student in the row, present last student. And how to check that? The last student should not have any ticket, right? So the last node's link part should be null. Like so, if we make t equal to null, then it will move ahead of the last student. So we need to be cautious about the logic that if we give t equal to until and unless t not equal to null, let's traverse. But no, not here, because if we use it, then the t will move ahead of the present last student, but we need to be stick at the present last student. So we need to give the logic like here, like the present last student has to have no ticket, and then it will traverse, like it will go to the first student and check if he has no ticket to be kept. Then if he has, then go to the second student, go to the third student, go to the fourth student. Suppose there were 4 students in the row and the fifth number is waiting. So if the bearer goes to the fourth student and finds that he has no ticket, so he will stop right there and then call the fifth student and give the fifth student ticket, that is temp, that the fifth student ticket is kept by the temp bearer. So call the temp bearer and give the fifth student ticket to the fourth student. Fourth student, that is the student right in front of he is standing, and this is how the student is put in the row at the end, like the to do node is put in the linked list at the end. And then again calling the fixed count to give him the proper 5 number, the proper numbering, because there is an addition, so need to give the number again. So this is basically the story of update to do, and this function will be performed repeatedly until and unless the user gives no. The user says no, this is enough of student, okay, don't call another student to sit in the row. Okay, so this is the story of the update to do function, and this is basically that's it of our to do list app. So if you like this video, don't forget to like, share, comment and subscribe my channel for more such little project related videos. I really prefer to learn concepts and then implement those concepts in छोटे projects. I really love to do that. And so sorry for the extreme delay that I've made in uploading videos, and I swear that from now on I will upload on every Saturday, Sunday new project related videos. And I'm also going to upload the snake games within 2 days, because there was some problem. I've already told what the problem was. So thank you for bearing with me. And again, if you don't understand at any point in this video, please make a comment below and go and revise your linked list concepts. That's what is actually needed. So again, thanks for bearing with me. I really talk a lot. So bye, happy coding.